Hello everyone. أهلا ومرحبا. My greetings from lovely Egypt, dedicated to everyone, everywhere, watches and listens to this session. Hope everything is going fine with all of you. As normal, safety first. Before starting this quick journey together, a safety moment regarding COVID-19, just a gentle reminder of keeping up social distance. Please follow health organization instructions. Kindly apply all rules of personal protection. I wish you all happy times. Fracture reservoir modeling. The title of this session. The agenda. In brief, fracture detections methods, fracture characterizations, fracture modeling, then way forward. We got 6 methods. 5 of them are indirect methods of fracture detection, and just only one direct method, which is the core analysis. Method number 2 and number 3, logs, which is indirect method, and cores, directed method. As you know, that FMI, the formation micro image, is superior in quantifying fracture density, and of course detect beds as well, but it hasn't that low detectable fracture spacing on imaging. Please keep in mind that open hole logs also are of a lower resolution than image. The method number 4, indirect one, through seismic. However, the amplitude cubes or the attribute cubes remain factor of the seismic resolution, but it's worth a trial. Number 5, the analog, still indirect method for fracture detections. Plenty of sub-items like the through the lab, the experiments, satellite image, the borehole data, field trips, outcrops, studies. Number 6, the well test. However, it's indirect method, but very important one, and gives that very important and efficient science of or for fracture detections. Well test. We have some types of the or for well testing. The interference tests that a test uses a long duration rate in one well in order to determine reservoir properties, such as degree of hydraulic communications and permeability and isotropy. That for well placement activities, also for optimal sweep. DST, drill steam testing, is analysis of pressure transient data from flow and build-up tests for indicating fracture presence. Second item of the agenda, fracture characterizations. However, we got 4 main parameters, but we have 10 sub-items or sub-parameters out of these 4 main parameters. So I'm going to browsing them in brief and quickly as following. Shape divided into 2 categories: unconstrained and constrained. Orientation of fractures. In order to identify the fracture sets, then assessing their impact of the permeability, which is very important. Number 3, fracture scale. Or from the outcrops, full trips, or measured from the logs. So the fracture varies from meters to kilometers, or from millimeters to kilometers. Here are great professors, Dr. Adel Ramadan, on one of the trips, illustrating, drawing how the effect of the bending, the folding, affecting on the fractures, creating fractures. Very comprehensive one. Still with the scale, size distribution. Then different fracture size based on different directions. Last one of the fracture characterization is the fracture spacing, or the density of that fracture network or fracture sets. Professor Mohammed Darwish, through one of the field trips to the carbonate outcrops, illustrated the fracture frequency with that equation and fracture density for all of us and the impact of that. How you can measure from the outcrops or through the core or through even seismic the spacing or the average spacing of the fracture. Very comprehensive one. Okay, third item, that the fracture modeling. Now we are moving to the applications. We start with analyzing the available data before designing or estimation any scenarios possibly for fracture modeling. Okay, the first and second initial data analysis are aiming to create illustrated maps for logs. However, the last step of the analysis goes for classification different sets of different main directions of the fracture. Why does this matter? It's important to evaluate and assess the uncertainties, also the potentialities of drainage ellipses of area of interest, your field. This is the reason. Classification and determination. Way forward. Until I get permission from maybe Schlumberger or some other companies, hopefully bring some real case study from Yemen and inshallah Egypt as well, in order to illustrate or construct, show how the 3D fracture attributes applied and constructed. Length or aperture spacing of that fracture is quite interesting and very important. Last slide of today actually illustrated the output probability final 3D model. Once you come up with that output, so the mission done or the job accomplished in one direction, in different directions, in any sort of scenario, you define your model or you design it. So this is actually the final result. Hopefully I can bring on that playlists, some real case studies later on, inshallah. I wish you found this interesting, maybe. Okay, keep well, stay safe. Bye.